welcome back. Today we're going to be doing something a little bit different from our usual. I've got this really cool demo here. This is a cool sort of effect. We're working in circular motion in class right now. The board spins around in circles. We're going to put people on the board and then get them spinning. They're going to try to throw tennis balls into that bucket there, and we're gonna see what happens because some interesting effects start to happen when we do this. So let's take a look.
It's like a curveball coming at me. Oh, good job, good job. Hold on, slide it off.
So in this case, I'm going to the left and Sophia is going to the right. I think that's fast enough. Alright, so I'm gonna have her try to catch. And it goes way off to the side there. If I try to throw it straight, the ball's gonna go way off to the left because I'm going to the left. Still going off to the side, so I'm gonna have to throw to my right. If I do throw it to the right, it'll curve off and come towards her. Ah, there we go. Yes! And it works. Alright. And if I try to throw it in the bucket, the same kind of thing happens. So she's kind of got the effect down, so she's able to make it now. And I gotta throw to the right now, so throwing that way. And oh man, when it bounces out, that's so sad. So it's pretty convincing. It really looks like there's a force on these tennis balls pushing them off to the side. It's really just due to our initial velocities. I'm gonna try to give a really brief explanation of how this works. This is called the Coriolis effect. So here's me from top view. Here's my friend on the other side, and here is the box in the middle. Since we are moving in a circle, that means every time I try to throw a tennis ball forward, it's not actually going to go straight forward. Since I'm also moving to the left, the tennis ball moves somewhat forward and somewhat to the left, kind of at the same time. So really, the path the tennis ball is going to take is going to look more like this. If you look from above, you can kind of see that this is what's happening. The ball actually does move in a straight line. It's not curving off. However, if you are looking from on top of the board, or if you're kind of visualizing what it would look like if you're sitting on the board, it very convincingly looks like the ball is curving off to the left. And the reason for this illusion, for this fictitious force called the Coriolis force, is that as you're going around, you're moving to the left with some speed, but also each point in the board is also moving to the left until you get to the very center. That box isn't going anywhere. That box is staying in place. Up here, this part of the board is going to the left a little slower. This part is going a little slower. This part's staying in place. And my friend on the other side will be going just as fast as I am in the opposite direction. Even though this ball is always going the same speed in this direction, it really looks like it's going faster than the board. Because the board, as you look forward, each point on the board is going a little bit slower. So it always looks like the board is kind of falling behind somehow, or like the tennis ball is ahead. So that's what causes this effect. Special thanks to the students that joined me. Thanks for watching, and I hope to see you next week.